Okay, this is the tutorial on how to do the data analysis for the acceleration of gravity experiment. And so I'm going to talk you through it here, and then hopefully you'll be able to follow along from the notes also in the laboratory handout. So we're going to use Excel. So I've got a link for Excel here on my taskbar, but you could start it from any other way that you normally would start a program. So this is Excel 365. And when you open it up, you'll see a starting window that'll look like this, which is, these are a bunch of recently used files I've used. But here you want to click on this option, which is for a blank workbook. So click on that, and this is your opening screen. And I'll move it down so you can see this. And so this is the menu bar here, and it's got all these different options. And this is the starting one with sheet 1, so you've opened up a workbook. And the first thing we want to do is we want to get the data that you took with Physics Toolbox Sensor Suite into Excel. And the way you do that is you import the comma-separated variables, the .csv files that you saved and uploaded from your handheld device, either a smartphone or a tablet, and then transfer it into the computer. So I've already done that step, and the instructions for how to do that are in the notes for the laboratory exercise. So the way you import the data once you've got it on your computer is you find this menu entry here, data, and if you click on it, you have all these different options, and it's really bewildering, but the one you want to focus on is here that says from text CSV. And if you hover over it with your cursor, you'll see down below it says from text /CSV, import data from a text, comma-separated variable, comma-separated value, or formatted text space delimited file. And so we're going to click on that, and it's going to open up this window. We'll open up this window. Here it is. And so it should say import data. And it's got all these different options of places to look. And I can look in my documents folder. I could look in anywhere along in here. And I happen to know that I put the files that I'm looking for in Windows, in Bates Teaching, Physics 221, Labs. And when I do that, it tells me, oh, look, here are two comma-separated variable files, 2020-7-1210.15.42 and 2020-7-12-10.17.48. These are the dates and times I created these files. You might have them named something different. It doesn't really matter. But what you want to do then is click on one, and the file name will show up here, and then you click on import. And when you do that, after you do that, it'll take it a few seconds, and it'll say connecting. And what it's doing is it's connecting to the file, and then it'll open up with this, and you'll have the file name here, .csv, and it should say something like this, 1252 Western European Windows, and then the delimiter should be comma, and it should say data type detection based on the first 200 rows. So Excel should go through and find these headers for the different files, time, acceleration in the X direction, accelerated in the Y direction, acceleration in the Z direction, and then the total acceleration, which is the vector sum of all three of these components. And we should have just done the vector summation unit in mechanics by Crowell, so you should be well aware of how to get from these three numbers to this number. Anyway, so it'll load up here, and now you'll see this button here, load, and so we'll hit load, and it'll work for a little bit, and it might give you this, and then it'll show up here where all of a sudden now you've got your comma-separated variable data. This is the time series from the phone, and it's read in as a data stream. And so we can shut that down because we're not going to need that. And then we can see that you've got all these different variables, these different values, right? So you've got the acceleration in the x direction, acceleration in the y, acceleration in the z. For this particular test I did, I dropped the phone from about a 2-foot height face up, so it was face up. So if we had our phone, and here's the phone and here's the face, I dropped it like this, so it came down flat on its back. And in that direction, acceleration in the downward vertical direction is positive, and it's a right-hand coordinate system. So if downward is positive there, then positive is a direction that way, and positive is direction that way. And for my phone, z is down, x is in the short axis of the phone, and y is in the long axis of the phone. So that's the orientation, and now we want to take a look at the data. And these are time series. So as a time series, you've got all of these different variables as a function of time. So time here in second goes from 0.012 seconds to 0.032 seconds to 0.052 seconds to 0.072 seconds. So every 0.02 seconds, there's a new data value, which means that this data was recorded at 50 hertz. There are 50 samples every second. And a quick way to look at the data when you have a time series data is to plot it, is to just make a graph. So we're going to plot the total acceleration, which is the vector sum of these three components, as a function of this variable time, right? And we can see that this is the vector sum just by doing a quick chess over here, which is one of the nice things about a spreadsheet, that we can say, well, let's take plus square root of b2 squared plus c2 squared plus d2 squared. And we'll see if it comes out to be 0.59. And of course it does. And now with a spreadsheet, the nice thing is you can copy it down a few rows, and you could look at that and go, boy, it sure looks the same. And then the other nice thing about a spreadsheet is say, well, let's look at the difference between that. So let's look at plus G2 minus E2, and we'll look at what the difference is between all those. And we can see the difference is really tiny, right? And if we wanted to compute the relative error, which is this error divided by the value itself, we'll see it's even smaller, slash G2. You don't have to really worry about any of this, but so again, it's, oops, sorry. Copy it over, and you can see it's a really small number. So this is the vector sum of those three quantities, and if you want to verify it for yourself, you can. But the first thing we're going to do in terms of data layout is to graph the data. And so to graph the data, you look to the Insert menu. So if you click on Insert, you'll see Recommended Charts. And the chart type you want is down here with this little symbol here, which is Scatter XY or Bubble Charts. And we want a scatter plot. And so we're going to click on the down arrow to open up the options for that. And the one you want is just lines. So it says scatter with straight lines. Okay. So we're going to click on that. And we're going to move it up to where we can see it and maybe expand it a little bit so it's a little bit easier to see. And now it doesn't look particularly useful at this point because we haven't imported any data into it. And the way we're going to do that is by right-clicking anywhere on the plot menu. And then you'll come down to the option that says Select Data here. And you click on Select Data, and it opens up this, and now we've got this entry here for blank series. And so we're going to click on that for blank series, and then hit Edit. And now it's going to ask us for a series name. Well, we're going to print the total acceleration, so we're going to tell it to name it that. And now the X values, these are time, so we're going to have it print these, or plot these. Now, we want to take the whole time series, and there's 4,000 rows. So we could do it by just dragging this down and wait 4,000, wait for it to go up 4,000 rows, but there's a shortcut. And the way to do that is to click on A1 so that you now that it's got that sort of flashing light going around it. And then hit the Shift key, it doesn't matter either one, and then hit End and down arrow. And that will go all the way down to the bottom and select that entire row. And then you come over to this Edit Series window and click this little down arrow, and it's filled that in right there. So now you've got X values are coming from sheet 2, which is what we just imported, from column A, rows 2 to A4347. So we've got 4,347 data points, 4,346 data points in there. And now we want to copy this, so we're going to highlight it, the whole thing, and hit Control C, and then we're going to come down to this and highlight it and hit Control V, right? And so now we've got X versus X. Well, that's not very useful, but the data we want is in column E, so we can come down here and change each of these A's to an E, whoops, to an E, and then we'll hit OK, and we hit OK again, and now we can see our data. And so what this shows you is all of these different repetitions I did of dropping my phone onto a nice big soft pillow from about 1.5 feet up. And so what you can see is you had this this funny little profile here where it looks like it's got this sort of little shoulder here, and then it's got this big tall peak associated with it, right? Okay. And so what's going on with that? Well, it's not very useful to look at this because you can't see a lot of the detail. So let's pick one of these and figure out how we can just focus in on this, say this one set time series here from about 15 seconds to 20 seconds. And the easiest way to do that is to click on the horizontal axis. And then you click on it, so you've highlighted this horizontal axis, which is time, and then right-click on it and say Format Axis. And it'll open up your Format Axis here, right? Your menu. And from that, we could say, okay, well, we want to go from 15 to about 20 seconds, so we can change the minimum time over here to 15 and the maximum to 20. And now we can see better what's going on, okay? So here is that one drop I did. And what you can see happening now makes a little more sense. That the phone rapidly, its acceleration rapidly increases and then goes to some constant value here. And then all of a sudden it shoots way up and then it comes back down. So it goes up to right around 10 meters per second. And then it goes up to about 100 meters per second. And then it kind of does this sort of little wiggling stuff, and then it calms down to have nothing at all. And then there's this small bump here. Well, what's going on? Well, here I release the phone, and it starts traveling downwards, and it takes it just a fraction of a second to reach the maximum acceleration of 9.8 meters per second. And it stays there pretty constant until it hits the pillow. And at that point, it accelerates very slowly to slow down, so the acceleration tops 100 meters per second. So in other words, the phone was peaking at probably a little over 10 Gs when it was slowing down, but it's in a nice hard case and it was on a nice soft pillow. It didn't hurt it at all. And this bounce here is it bouncing up and down a little bit on the pillow until it stops. And here's where I picked it back up to get ready to try and drop it again. So this is what you want to see in your data. And the data analysis from here is really pretty simple, is you're going to look at here and go, okay, well, it looks like it's pretty constant from about 15.6 to 15.7 seconds, maybe, all the way out to almost 16 seconds, right? So you're going to look at what that acceleration is. So from there, you would go over here and just hit page down. You get to about 15.7 seconds, right? So here's 15.693, and it's 10.3, and then it goes to 15.7, which is what we said, and it's 9.8, 9.707, 9.726, all the way out here till it gets to about 15.95 or 15.97 here. So if you look at this data here, it looks like it was hitting, it started to hit the pillow and it started to, its downward acceleration was decreasing, and then all of a sudden it had this large upward acceleration where it was slowing down to stop. And so what you would do now is say, okay, well, this is sort of the acceleration I measured, about 9.7 or 9.6 to 9.7 meters per second. And so you record this somewhere in a notebook or something as trial 1, and then the acceleration was of order 9.7, and the units are meters per second squared. Okay. And so you'll fill that number in on your data sheet in the lab notebook, and these will be your measurements, right? And this is how you process data. Now, if you want to get fancy about this, you can use the functions that are in Excel and compute averages. So you could say, well, from about line 785 to about line 793, so 785 to 793, that's sort of the data I want to take. So let's compute that average. So, and we would say average E 785 to E 793, right? And it'll highlight that and tell us those are the values we're going to average, and it'll tell us 9.664. So we might cut that down to 2 significant figures. We'll go up here and we'll say, whoops, other way, 9.7 meters per second. You could sort of eyeball it. The more professional way to do it would be to use Excel's function and calculate an average. You should get something that's right around 9.8 meters per second. There's no reason that our acceleration due to gravity would be anything different, much different from that in where we're doing it. So the reason it's a little bit lower probably might be air resistance. It might be that it never really reaches its not terminal velocity, but it's always feeling the effect of air resistance as it's accelerating. Anyway, so that's how you do the data analysis. And then when you're done, what you want to do is you want to save the file. So you can go to File, Save, and it'll come up and ask you for a place to save it. So you could say Labs, and you would go Test, or you could call it acceleration, of gravity lab test. And it will save it for you. And then once you've recorded these values in your lab report, you can click Exit, and you're done. And we just say Save again. Okay. So that's how you do the data analysis in Excel, and hopefully you will be able to use that to do your lab report. Thanks.